Hey, everybody. Welcome back to another episode of the Horse Geeks podcast, where we look at horses and riding from the inside out. I'm Kirsten Nelsen, professional horse trainer, and with me today is Deb Romero, certified Alexander Technique instructor. And today we're going to review a scientific paper. So this is what Deb and I love to do this is our full geek
I know
flag.
we get so geeky around this stuff.
I
Like,
know. Ooh. This
so
is a great
cool.
paper. Let's look at this. What does it mean? So it's been one of our objectives of this podcast, which kind of started because I just missed you, Deb. Deb's in Virginia, I'm in Florida, and we've had to learn to work and catch up remotely. So that's what sort of started this whole podcast idea. And so today we're going to review a scientific paper, which is kind of what Deb and I just do for fun.
I know, right?
I know.
Sick
So
brains.
that's why it's Horse Geeks, right? Okay, so the topic, the title of the paper is, it's long.
It is.
It's muscle fiber type distribution of the thoracolumbar and hind limb regions of horses, relating fiber type and functional role. So that's what kind of caught my attention, that even made me download this paper to read it, was relating fiber type and functional role, because I'm always interested in understanding more any inherent functions of the body, because the form function principle. So the body has a specific design that tells us how each body part should also ideally function. So that form function principle is at the heart of understanding biomechanics, which helps us understand good movement or poor movement, optimal function versus dysfunction in how our horses are going.
Yes.
Right. Which is important, not only for, it could start because you just want to enhance performance, like top human athletes.
Right.
They just want to enhance performance. So they're going to learn more about form function and how the mechanics are supposed to work. But what it came down to for me was overcoming behavioral issues, overcoming lameness issues, and really just for the essential functional well-being of the horse, of the ridden horse or working horse. And I think not understanding that is inadvertently, I don't mean people go out with this idea, but it's inadvertently cruel to our horses.
Because well, I can apply that same thought to people,
Yeah. And so what do you mean by that? Like, how would you apply that?
Well, I just think it's it's so meaningless the way we walk around and use our bodies all day long, and we don't pay any attention until something breaks, hurts. If we went more into, and I think that's where you're going, is preventing these things from happening by using ourselves the best of our ability at that time, I'd rather be on that side of the fence than the other side of the fence.
Yes. Yeah, that there is a lot we can do through functional movement that to actually support our health, our horse's health. Soundness is what we call it when the horse isn't lame, and soundness is what we call it when a human isn't in pain. Same thing, right? So just to have a better sense of well-being, safety inside our own skin, and soundness, it's like, yeah, we actually can have a massive influence over that just in daily use of our bodies with how we move. And that's what's so funny. When I took the Alexander Technique lessons, it's like, it was singularly the most helpful thing for my riding skills. But what did I do in the lesson? I learned how to walk I learned how to sit. I learned how to stand. I learned how to pick up objects. It was like, it was such a nothing, so to speak, lesson, but totally changing some of my physical habits of how I use my body, which makes all the difference.
Exactly.
So let's tuck into this paper. I'm going to need my glasses. Oh, and I forgot to give credits. I don't know if I can say all these names. So again, the title is Muscle Fiber Type Distribution of the thoracolumbar and hind limb regions of horses, relating fiber type and functional role. And the authors are Heli. Oh, I'm going to hack this. I want to say this paper is based out of Finland.
I think so, yeah.
Yeah.
It says it's yep, Scandinavica.
Yeah, no, Helsinki, Finland. So
Okay.
yeah, so these are Finnish names that I am going to just hack, but Healy K Height. Oh, okay. Hyytiainen. Anna, Mykkanen. Anna K. Hielm-Bjorkman, Narelle C. Stubbs, and Catherine M. McGowan. I think she's the American in the mix.
I would
So anyways, I had to spell what I can't say. And basically in the abstract, it starts off that the predominance of a fiber type can indicate the primary function of a muscle. So there's muscle fiber types, MFT1, which are postural or what we call tonic. So MFT1s are slow twitch muscles, which have a long duration of activity with low energy. And then there are MFT2, which are the locomotion muscles or locomotory, or phasic is what they're called. And those are more the fast twitch muscles, which are related to movement and locomotion. So what they're looking at in this paper is it hadn't been determined in horses, although it had been in people. So they were sort of looking at, is it similar to the muscle type distribution in people, where the postural MFT1 muscles are compared to the locomotory or phasic muscles, MFT2, in the body, sort of telling us where does the body have to stabilize and where does the body generate more movement. Does that kind of,
yeah, I like
anything you want to add to that?
keep it simple.
Yeah. I know. I
Keep
love
it simple.
papers, but it's like I have to make notes and I don't want to use too much of the lingo. I want to keep it
Yeah, you
simple.
gotta keep it in layman's terms.
Right. So one of the results that made me want to talk about this paper on the podcast was there were two muscles that had the highest proportion of the MFT1s, which is the tonic or the postural muscle fibers. And that was the diaphragm.
I know, right?
And, okay, I'll say this once and then we'll abbreviate. The sacrocaudalis dorsalis medialis, which is the MSDM muscle. Just remember MSDM. And that muscle is basically, it runs from the third sacral bone, so from the sacrum to and along the coccyx spine. So it's basically the tail head, right? So the tail head and the diaphragm had the highest proportion of postural muscle fiber types.
Yep, and I think another one that was in the mix was the multifidus.
The multifidus also
Mhm.
has, I think it was the multifidus and the psoas minor,
Yep.
which in the human is just kind of a non-used muscle, the psoas minor.
Either that or it's not present.
It says, yeah, in fact, I'll quote, the psoas minor is present in only 50% of humans,
Mhm.
whereas the function and relevance of the muscle is considered minor in humans. Corresponding information on horses was not found. And based on the findings in this paper, it has a high MFT1 proportion. So what that means is it's part of the important postural muscle structure. So we've got the diaphragm, the tail head muscle, the psoas minor, which in horses obviously has a much more significant role than in humans,
Mhm.
and the multifidus.
Yeah.
Was that? Yeah. So the multifidus muscle runs right along the vertebra of the spine. It's a
Mhm.
very deep, what they call hypaxial back muscle.
Mhm.
It might be in the epaxial, I'll go over that. But so epaxial muscles of the back are situated above the line of the transverse processes or the spinal processes.
Mhm.
And then the hypaxial back muscles are situated below the transverse processes. So that it's just describing the location of the back muscles. So
Right.
the deeper back muscles below those dorsal bony tips, the spinous processes, closer to the vertebra bodies, that's where the multifidus muscle is in the well, technically, I'm not sure if it's hypaxial or epaxial, but that's where it is. And that had one of the greatest proportions of the MFT1 types or the
Right.
postural
Which that one
type.
that chain, the multifidus chain that goes down the whole spine, that completely makes sense to me, because what I found in my work is the muscles or structures, ligaments, whatever, that are closest to the spine are more postural. And those that are further away from the spine are more locomotive. And maybe that's easier to remember, but the diaphragm totally blew me away.
Yeah, so let's circle back to just those first two muscles of the diaphragm and the tail head muscle, the MSDM muscle. The farther away from the middle, the longer the name. Diaphragm muscle, very close to the center, one name. Sacrocaudalis dorsalis medialis. Yeah,
Medialis.
medialis, sorry. My anatomy teacher will have to correct my pronunciation.
It's just another language.
Well, and it's descriptive. So
Yeah, it's location descriptive.
Right. So sacrocaudalis means the caudal side of the sacrum. The caudal is the tail side. Cranial is the head side. So sacrocaudalis just means back side or tail side of the sacrum. Dorsalis just means the top of the body, dorsal versus ventral, the bottom of the body. And say it again, medialis.
Mm-hmm.
Okay, medialis just means towards the center, the medial versus lateral. So medial means towards the center, lateral means away from the center. So all of those directions, like the muscle sort of describes, the name of the muscle describes the location of the muscle.
Yep.
Yeah, and that happens the farther you get from the axial skeleton. So what was your take on those two muscles having the most postural fiber types?
Well, when
What did that mean to you?
when I do my best thinking when I'm mucking. So I was out mucking this morning going, okay, really, that makes a lot of sense. But because in most other animals that have tails, that's a stabilizing factor.
Absolutely.
why don't we think about that with our horses?
Absolutely. That was the first thing I thought of too, is like,
Really?
yeah, if you look at the slow motion videos of a cat falling,
Yeah.
the tail is a huge part of that rebalancing mechanism.
Hmm.
Yes. And it is for a horse. Like
Yeah.
they flag the tail, move the tail, and remember that's tied right into the sacrum. And it's the coccyx part of the spine.
Right.
We forget that the tail includes the spine.
Yeah. And I can this and with the diaphragm thing, I just never put this together with horses, but in people, the diaphragm attaches at the crura ligament with the psoas.
Mm,
So the relationship between breathing and the psoas muscle in a human is a big deal, because if we have the psoas contracted, we're shutting down the diaphragm.
interesting.
Yeah.
And does that work in reverse if you have shallow, rapid breathing, or you contract overly? If you keep the diaphragm muscle overly contracted, does that affect the psoas, which is more postural?
I've never thought of it in that way. The relationship I see with people is once I teach them how to release their psoas, they'll usually take a deep breath just automatically.
Interesting.
Yeah, and that's when I know, okay, they understand the relationship between the psoas and the diaphragm.
But that might also be related to why a lot of people say if they change their breathing on a horse, the horse responds. So it could be
Mhm.
working the other way around, that it's changing the tone in the
Yeah,
psoas muscle by increasing the use of the diaphragm.
yeah,
So, and the diaphragm muscle on the horse is really huge, and it sort of moves. I would assume it's tied in exactly the same way to a horse's anatomy as it is what you described as a human.
it looked like it in the pictures I looked up. I was like, oh, well, maybe that's the relationship going down to the tail too.
Yeah, although I think the tail is more tied into the multifidus muscle
Hmm.
than the
They did
diaphragm,
they did say in this paper that it was kind of an extension of
the multifidus
the
muscle.
multifidus muscle. And yeah.
Well, the first thing I thought with the tail head muscle, the MSDM muscle, was horses really do have a rudder. Like I sort of use that metaphor, for
Yeah,
stabilizing the pelvis, increasing engagement, and also for steering from the saddle. The direction is determined more by where the tail is placed on a path of travel than anything else. And so
good
I
point.
always refer to the tail as the rudder. And so I went, oh, it really does kind of act like a rudder,
Yeah,
because
yeah,
it's going to influence the stability of the very end of the spine, and being tied into S3, this third sacral bone. That's going to go right up the spine as well.
hmm, yeah,
And it's interesting when you change, when I'm working with rehabbing a horse and influencing spinal functions, a lot of times, like some horses that have crookedness issues, lateral bending or rotation through the spine, will also hold their tail chronically to the right or the left.
I can speak to that because my big mare, her tail was always cocked to the right. And later what we found out is that her thoracic, her withers, is rotated to the left.
So she was using that as a counterbalance,
Yeah.
which is exactly what I find all the time.
And it's so interesting to find that out. That's how she was adapting and moving. And we are constantly working on that.
Absolutely.
That is a habit that just comes right up as soon as I get on her.
Because it's how she learned to stabilize.
Yeah.
She's what you would call severely left-handed.
Yeah,
right?
just like me.
Yeah. Yeah. So she's very left-handed. And so if the upper thoracic spine is stabilizing too far out of center to the left, then that postural strong tail head muscle can offset that by
Mhm.
being chronically held to the right. I just find that's
It's amazing.
fascinating.
Yeah, it is. And like I said, it's every ride, every step, that thought is in my head of, and you've always said, always put the front end in front of the hind end. And that's really important because sometimes you can't get the hind end to move where the front end is to get
Exactly.
straightness. So I
Much
really,
easier, much
yeah,
easier to move the front end, which is more mobile, than the
yeah,
hind end, which is supposed to be more stable.
yeah.
And wherever the horse, if the hind end shifts left or right down your straight path of travel, wherever that tail is pointed is where that horse is going to go.
Hmm.
So if the tail, shifts off to the left, that horse is going to keep tracking or falling or pushing to the right.
Hmm.
So, and that's what when I went, oh, wow, that tail head muscle is actually being most significantly the fiber type of tonic or postural. I
Hmm.
went, that's fascinating. That suddenly, like, the penny kind of dropped.
Yeah, it did. Me too.
And I go, so watching the tail is because a lot of people think if the horse moves the tail, they're mad. And I go, no, the expression of the tail can have just as many meanings as the expression of the ears or the face or anything. But it's
Right.
interesting in sort of guiding horses into changing the use of the spine. Tails that are chronically left or right will start shifting the other direction
Hmm.
or finding center. The horse, when they really go into extreme downward force of the spine or longitudinal extension, the tail will make a backwards J,
Yep.
which is sort of just an extension of what's going on in the thoracolumbar spine. Or a lot of horses with chronically tight backs, as the back begins to release excessive contraction and the muscles restore some suppleness, sometimes the tail goes crazy. And
I've
it
seen.
just, starts flagging and moving around a lot. And I'm wondering if they're using, that more postural muscle to sort of send energy up the rest of the back rather than the
That's
back
interesting.
being reflected in the tail. I'm wondering if the tail is influencing the back.
That's an interesting thought. I know when every time I get off this big mare, the first thing I do is I go walk around and look at where her tail is.
Mm. And you kind of know how your ride's going
I
to
know
go.
how my ride went. It's like, oh, spot on, yes.
Yes.
Or
Yes.
crap, I didn't make it today.
Yeah. Back to square one.
Yeah,
Back to repetition.
yeah.
So then the other thing I thought of with the diaphragm muscle, the first thought that came into my mind is I thought, this is why that theory that the abdominal muscles lift the back is so prevalent.
I think you're right.
Because I go, that diaphragm is huge. So it moves from sort of it the length of the diaphragm muscle is quite long, going from the lower lumbar spine, sort of oblique towards the sternum, right?
Yep.
So it's a huge muscle. And that's why the psoas is right in that area as well. So I'm thinking what you described with the diaphragm tied into the psoas and
It's attached by the crura ligament, and it attaches in a human. I didn't specifically look at horse, but the human, it attaches to the lumbar vertebral body, the actual body of, well, like where the disc is, if people can envision that, not to any of the bony processes sticking out. It attaches to the body of the lumbar vertebrae.
Oh, I'll have to look that up because
Yeah.
the quick diagrams that I looked up online basically showed that it started in the lumbar vertebra and moved sort of forward in a diagonal line towards
Yep.
the sternum.
Yep. And down.
Yeah.
Yep.
And it was huge in the horse.
It is
Like
big.
it's a very long muscle that moves sort of from back to front through the barrel. And so I thought, wow, if that muscle is part of the stabilizing mechanism of the body, which is what postural muscles do, or we could say slow twitch, tonic, MFT1 type muscles, all the same thing. That if that's sort of toning to support stability during motion, you might see the thinner, more outer muscles of the diaphragm contract, or not the diaphragm, sorry, of the abdominal muscles. You might see them contract, but it's not the belly lifting the back.
Right. I think that's the important myth buster right there.
Yeah, it is a bit of a myth buster.
It is.
Yeah. Yeah, because it's really the epaxial and hypaxial and even the intervertebral muscles
Yes.
that change flexion, extension, rotation, lateral bending, create alignment and stability, or they don't. And so that those upper back muscles are actually what directly influence the functions of the spine. But I thought, interesting that the diaphragm is part of that stabilization mechanism.
Yes.
That I found fascinating. And it really, I go, well, no wonder this whole sort of like belly lift and tighten the belly and strengthen the abdominals and all of that is still a very prevalent belief system of how horses lift their back. It's everywhere at many levels of riding. But when we actually look at the function, and that's what attracted me about reading this paper on fiber type and functional roles, was the fiber type is telling us no, because I think the abdominal muscles, like the outer muscles of the body, it's an MFT 2X.
2X.
Right. So they get into like the outer muscles, which are pure locomotion, are going to be type 2X, double X, triple X, all these Roman numerals, the farther out you go. So,
yes.
Right. So what they're really looking at is what are the primary postural muscles and what are the primary locomotion muscles?
Yes. And there was one part in there that really spoke to me is they also mentioned that the type of exercise, selection and breeding, and the way we train can also affect muscle fiber type.
Yes.
And I can speak to that because I'm vertically challenged.
Not tall.
When I lived in New Mexico, I had a friend that was a cyclist, and she's tall and skinny. So when we would go on the straightaway, she'd kick my butt because she had more of the long twitch muscle fibers, and and I'd just be struggling. But if we got on any hills or mountains, I could just go right by her because I've got more of the short twitch muscle fiber. So it can be in the breeding.
Yes.
And the type of exercise that also affects it. And I thought that was fascinating.
Yeah, I actually made a note in the paper because they did take muscle from 3 different breeds: Arabians,
Right.
quarter horses, and thoroughbreds.
Right.
And what I found fascinating was, where did I make my note? That the inner muscles, when they looked at the primary locomotion muscles and the primary postural muscles, which are all around the spine and the diaphragm, but not the belly, those were the same breed to breed to breed.
Pretty much, yeah.
what was very different breed to breed were the outer MFT2 type muscles,
The locomotive
the
muscles, yeah.
locomotive muscles. So those were different breed to breed, but the postural and primary locomotion muscles were the same. And I found that really interesting.
Yeah, that kind of makes sense because that's kind of like the survival of the species, you know? You have
Absolutely.
to have that stability to have locomotion.
Right. So it says here the major classification of muscles according to their functional roles was not affected by breed, and the same general pattern with all horses was seen.
Yes.
Oh, and then I did underline the same part you were talking about when prescribing physiotherapeutic
Yes.
exercises to rehabilitate the muscles of the horse's back. Based on the results of the present study, exercises could be targeted based on MFT, specifically altering amount, speed, and resistance of the exercises used.
Yeah.
Yeah, and that's basically what we're doing to improve the movement of the horse is how they manage the forces of motion.
Mhm.
So if they're symmetrical left to right or asymmetrical,
Mm.
if the braking and pushing forces, which is your upward and downward transitions, if those are balanced, then you're working those back muscles.
So when you say balanced, what would be a good description that your whoa and your go are equal?
If I put it in the simplest terms, what we're looking for with balance is the body has 3 dimensions. So we can think of the body in 3 planes, right? So we have a front, back, a left, right, an up, down. So for horses to balance, the forces of motion, which are related to the functions of the spine, there's lateral movement in the spine called rotation and lateral bending, that those forces have to be equalized left to right so that the spine is functioning symmetrically and not asymmetrically, like your horse's tail tells you how the ride's going to go. Yeah. Right? Then in the front back dimension and the vertical dimension, horses have to push forward, generating a forward force, technically called pushing, but they also have to control their own body weight and stabilize the body during motion, which is the braking. So there's a stride phase and a muscle use that are both called pushing phases, braking phases of stride, or pushing use, braking use of the muscle. In this paper, they're talking about it as postural, which is stabilizing, which would be part of the braking mechanism, or locomotion. And what was fascinating was all of the hypaxial and epaxial back muscles were almost equal in the muscle fiber types for both postural and locomotion.
Yeah.
Except the
That's kinda
multifidus, which we talked about, the deeper one along the spine, in, I think, the upper part of the multifidus muscle was more type 1, and gradually that ratio of type 1, type 2 became more equalized as the length of the muscle moved caudally towards the tail.
Yeah. I find that fascinating. How adaptable is that?
Yeah. And it makes sense.
Pretty incredible.
I mean, horses are highly efficient movers.
Yeah.
Highly efficient. That's why they can go long distances at fast speeds, even though they're huge, heavy animals. And it makes sense that there's only really the tail head muscle and the diaphragm are primarily all postural muscle fiber types. So those are going to stabilize the body during motion. And then the muscles that influence the functions of the spine are almost equal between locomotion and stability, or postural stability. And that the psoas minor is tied into that as well. So that function of muscle fiber further confirms that the work we do to lift the horse's back, which is increasing longitudinal flexion, the work we do to help a horse travel straight or do lateral work, which will include lateral bend and rotation, all of that is the work of the back muscles above and surrounding the spine.
Yeah. And that holds true pretty much for humans. Like I said, I see the postural muscles are all close to the bone.
Yes.
And the locomotor muscles are, further out.
Right. So we may see that little line under the rib cage of the horse's abdominal muscles contracting, but I think that's a result, not a cause.
Yeah, that's a good way to put it. I completely agree with that.
Yeah.
Yeah.
It's
a level of support, but not, it's actually in, I think in the next paper that we're looking at doing, they call them the antagonistic muscles. And antagonistic muscles are supporting the other muscles that are contracting by their lengthening to support.
Is there a protagonist muscle?
I don't think they call it that.
They probably call it something else.
Yeah. But I found that fascinating that it's actually the abdominal muscles are there to support the viscera.
And that's exactly how it was described to me by one of my mentors, Gavin Schofield, is he said, you see the abdominal muscles working, but it's really acting to normalize the pressure in the abdominal cavity.
That's a good way to put it. Exactly.
Yeah. It's just normalizing all that pressure around the vital organs, the heart, the lungs, all of that.
Kind of like so the bowl doesn't slosh.
Yeah, so the bowl doesn't slosh. So your guts don't bang back and forth, right?
Yeah.
Exactly.
I found that fascinating. It's like, oh, that's cool.
So I had a question for you too. I made a note. There was something I read that I was hoping you could explain a little better, and I'll just read it and see what you think.
Okay.
The function of the thoracolumbar and lumbopelvic regions during locomotion is complex and requires a coordinated relationship between neural and muscular motor activity, which is referred to as neuromotor control. In both humans and horses, the muscles involved in dynamic stabilization have a high MFT1 postural content and a high number of muscle spindles, indicative of their complex role in neuromotor control. So I guess because they don't really go into muscle spindles in this paper, they're just looking at muscle types. But I found that fascinating that the MFT1 type muscles, the postural muscles, tend to also have more muscle spindles. And so can you kind of explain how muscle spindles relate to neuromotor control?
They're stretch receptors. So they're the things that communicate. You can kind of think of it as, I actually did this morning cooking breakfast. I almost burnt my arm. You know that that was my receptor. I went to reach over a pan and hit it, and I went, well, that's a receptor going off saying, yes. Don't do that. Yes. So the stretch, there's also something I don't want to get too deep into. The Golgi tendon reflex too is sending messages to the brain that it's being stretched too much. And to shorten, it's those neurotransmitters going back and forth saying what's being stretched, what's being lengthened. It's a really complex system, but they have more receptors. That's what that
So means. Then that also makes sense to me in that when we're riding and working with horses, we're really working with the forces of motion more than anything else.
Mhm.
because you can't move and manipulate body parts. We think we can, but you really can't. It's like, you can't influence precisely how muscles respond,
Right.
or that internal coordination related to spinal functions is not directly under the rider's influence. So it's kind of a chain of events where we influence the forces of motion. The forces of motion are generated by changes in muscle use.
Right.
The change in muscle use is what influences or is directly tied into the function of the skeleton or the bones,
Right.
primarily the axial skeleton, the skull, the spine, rib cage, and pelvis.
Mhm.
So in that indirect sort of way, it again sort of confirms that if the muscles of the back have the highest ratio, even though they're locomotory muscles, they still have the highest ratio of postural muscle fiber type.
Yes.
So influencing the back muscles is how we change the posture use function of the horse and influence the nervous system.
Yes. And if you think about it, it's a core primal thing too, to have all of those spindle cells and receptors, because to survive, you have to have a spinal cord. And the spinal cord is housed in the spine. So you want as much information for survival
Which is
of
why it's also deeply protected
yes.
by the body with huge, these epaxial and hypaxial back muscles are huge.
Mhm.
These are the big, thick steaks you buy off of a cow's back, right? They're big muscles.
Well, the psoas is the tenderloin of a cow.
Yeah.
So you know, that's how big it is. And I tell people when visualizing their psoas muscle, it's as big around as your fist when it goes through the pelvis. That's
Yes.
pretty darn big.
No, and as opposed to the abdominal muscles themselves are really quite thin.
They're very,
They're they're not super
they're
thick.
sheet-like. Yeah, they're
They're
more
more sheet-like.
sheet-like.
So if we do nothing else in this podcast, I really want to dispel the myth that the belly lifts the back. Like, it just doesn't. Mechanically, it makes no sense. The research, and this is what we're talking about with even the muscle fiber type, it's the wrong muscle fiber type for postural support in the abdominal muscles.
Right.
The correct muscle fiber type for postural support, which is self-control, which takes us back to the podcast on self-carriage. Those fiber types live in the back muscles.
Right.
Now, because it also lives in the diaphragm muscle, that might create a visual effect.
I
That
think
I
it
think
did for me when I looked at the visual of that this paper gave me. I said, oh, well, that makes sense why people might be confused.
exactly. It finally explained the perpetuation of that myth that the belly lifts the back, because what we might be observing from the outside of the skin is the use of the diaphragm for postural support.
Yeah.
Right. And then the tail head, that just kills me.
Well, it makes sense. I just never thought of it in a horse,
Right.
Think of it in monkeys and things like that. Obviously use
But
their
it makes
tails.
sense because any animal with a long tail, I mean, as humans, our tail is almost non-existent,
Right.
but quadrupeds very much still use their tails.
Yep.
Bipeds, not quite so much unless you're kind of in between, like a monkey. But but yeah, cats, dogs, horses definitely use the rudder for stability as well as steering. So is there anything else? I'm kind of looking through my notes to see if there was anything else I wanted to add.
Just that big thing about, really sticks to me, the type of exercise, the selective of breeding, and your training really influences muscle type.
That you can, so are you saying, and I think I read that in the paper. I don't think I underlined it, but that how you train the horse can increase specific muscles in fiber type.
Yes, and it's the same with humans. I mean, look at somebody that
Like
decides to
a
become a
bodybuilder.
bodybuilder.
I was going
Yeah,
to say bodybuilder or weightlifter versus gymnast or
right.
runner.
Or when I was bodybuilding back in the day, there was a young lady, tall and skinny. She was a deputy sheriff, and she would come in and she could lift as much weight as me. I was doing 20-pound bicep curls, and I'm building all this mass, and she's looking at me going, how do I do that? And I'm like, you just don't have the right fiber type. I'm sorry. I wish I was tall and skinny like you. Come on.
But you're saying that that can be altered through
You
training.
can, yeah, of course. Just
Yes.
like the difference between, any kind of Olympic thing. You can see
Well,
the
and it,
difference in a swimmer as opposed to, somebody who throws the kettlebell or whatever. I
right.
mean, they're completely different. And you can see it in the mass where they have more mass in their bodies.
Yes.
But that's also in horses.
And that takes us back to the form function principle, that the muscles can change based on the function.
Right.
But the function is already also inherent
Right.
in specific locations of the body.
Right.
So let's wrap it up. This is where in the paper, they move into the discussion section. And I found this first part of the discussion section super interesting. So I'm just going to read it. It basically says, a fiber type distribution typical of a predominantly postural stabilizing function was found in the diaphragm and SCDM, but the rest of the deep epaxial and hypaxial muscles only had approximately equal portions of MFT1 and MFT2, indicating dual postural and locomotory roles.
Yes. I think that's quite
Um,
unique.
As expected, the superficial epaxial and hind limb muscles studied had a fiber type distribution indicative of a primarily locomotory function. Based on previous studies on humans, it is possible to assume that with such high MFT1 content, SCDM could be rich in muscle spindles and would therefore also have a proprioceptive function. However, muscle spindles were not analyzed in this study.
So like and you said, it's the rudder. I like that.
Yeah. Yeah, and it's
sending
interesting.
Directional information.
Yeah, and that has an influence proprioceptively.
Yeah.
Which means sort of proprioception is where we feel our bodies are in time and space, which is directly just the nervous system.
Yeah. And that's survival. I mean, if you think about it, that's
right. Which is why, when you monkey around with rider balance in the saddle, the brain screams out, wrong, 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 wrong. This can't be right when you go to change functional habits. And
I think horses probably do the same thing.
Absolutely.
Yeah.
But yeah, if you walk out and your horse has her tail over to the side, that's why it's not going to be an easy ride, because her nervous system is back in that old habit.
And then the old habit. And I think that's a real mindset for people to check in with their horses every time, because just because you quote unquote fixed the problem in the last ride doesn't mean that problem is gone.
Absolutely.
It can be a completely ingrained habit.
Habits are habits.
Yeah. And it's the same for us. When I'm working with clients for years, even that habit may not be as big, but it could still be there.
I had a really interesting thought the other day. I had to look up Newton's first law of motion, the law of inertia, which we've talked about. And it suddenly occurred to me, that's why habits are so hard to change. It's just that principle of a body in motion tends to stay in motion in the same direction at the same speed until acted upon by a net force. And I go, that's a habit. Like a habit is a little object. It's a, what do they call it? A central pattern generator. A CPG is like a little packet of information running through the nervous system that is the director of how we move, how we coordinate our bodies in motion. And so I went, oh, a habit's like this little packet of information going through the nervous system. And until we act on it with net force, it's not going to change.
And as an Alexander teacher, that net force is a pause.
Or it's basically we have to spend a lot more energy when we're changing habits. That's why we have to spend more energy. We have to generate a net force, whether that's mental or physical. I don't think it matters. Energy is energy. But I just thought that was so interesting to think of, inertia. That's why it's hard to change habits. That's why it takes more mental energy, more physical energy to change a habit than it does to use a habit. A habit is a highly efficient way of functioning.
Yes.
And that's why we love our habits, because it's efficient. It doesn't take as much energy. It just sort of rolls along on its, in the same direction at the same speed until acted upon by a net force.
Yep.
But yeah, I thought Newton's law of motion really does apply to habits. Oh, there was one last thing that was sort of an afterthought in this paper. In human studies, side differences within a subject have been shown to be present. For example, the psoas major has been shown to have a different MFT proportion on the subject's left side compared to the right side.
There's a habit for you.
There's a habit.
That's like the podcast when I talked about the lady that the doctors told her forever that she had one leg longer than the other.
And you could maybe trace that right up to the postural muscles of the
it
psoas
is.
and the back muscles.
Oh, yeah.
That it's just a muscle fiber type conditioning.
Yep.
So interesting. And the guy says in his paper, or the ladies or the group, that they didn't collect samples from both sides of every horse. They randomly alternated sides, but they thought that was something that required further study.
That would be interesting.
Yeah, because that's going to be directly related to habitual rotation function and lateral bending function.
Yep.
That you're going to have different muscle fiber types in your primary stabilizing and locomotory muscles. Oh, well, I love this podcast. I love geeking out with you over papers and talking about it.
Me too.
So please if you liked this topic. If it was way too out there, put in a comment, but we'd love to know what you think about research paper reviews, because Deb and I really like doing that.
Yeah, I know, right?
And thank you. Welcome to all the new subscribers. That has been awesome. I've really loved the comments. The thumbs up kind of helps spread the word. And if you like today's podcast, we will do more of them because we love reading research papers.
Yes.
And we will also throw in the practical podcasts that are directly related to our everyday experience, because I've gotten some great comments on that's been helpful to people. So thank you for joining us. We look forward to seeing you again. Please like, share, subscribe, and we really hope you enjoyed the podcast. Thanks, everybody.
Bye, everybody.